Our next ratio test example is this. We have factorials all over the place. So this is a perfect candidate for the ratio test. We have 2n quantity factorial, we have 4 raised to the n, we have n plus 1 factorial. So we need to compute the limit as n goes to infinity, and my great big complex fraction. The numerator is 2, n plus 1, distribute the 2. So it's n plus 2 factorial. This becomes 4 to the n plus 1, n plus 1 plus 1, divide by, copy, paste. So this is 2n quantity factorial over, we have 4 raised to the n plus 1 factorial. All right? So now let's see what we get out of that mess. We have the limit, complex fraction. There's nothing for the absolute value bars to do. Yes, you do include them when you write the expression out, but we recognize there's nothing for the absolute value bars to do. So from this point on, we suppress them and we write the complex fraction. This is 2n plus 2 quantity factorial. We played this song on the previous example, so it's going to be very similar. This is 4 raised to the n plus 1. We have n plus 2. This is factorial also. And then multiply by reciprocal. So I have 4 to the nth power n plus 1 factorial, the numerator. And 2n quantity factorial in denominator. We have seen this already. 2n quantity factorial into here. This is 2n plus 2, 2n plus 1, and then 2n factorial. So when this cancels here, leaving 2n plus 2 and 2n plus 1. So we're left here with 2n plus 2 in the numerator, 2n plus 1 in the numerator. Now, when you divide the bases, subtract the exponents, the leftovers go where the larger number was. So n plus 1 minus n plus 1 minus n is 4 to the first, and it goes in the denominator because that's where the larger exponent was. So we have a 4 to the first left over. And then this is n plus 2 times n plus 1 factorial. This is n plus 1 factorial. It's not very hard to see. This is n plus 2. And now we're back to dominant term divide by dominant term. Make sure to distribute the 4. So if you multiply this out, when you multiply the two dominant terms in the numerator, this is equal to the limit as n goes to infinity of 4n squared and some other lower degree terms, divide by, distribute 4n and lower degree terms. So we have dominant term over dominant term. I'm going to go ahead and write this here. This is equal to the limit as n goes to infinity. The 4's cancel. This n cancels with one of those. So we're left with n in the numerator. As n goes to infinity, n goes to infinity. And I don't know all the mathematics in the world, but I know infinity is bigger than 1. So therefore, this series diverges. Now, it doesn't need to be infinity. Any value bigger than 1. If this had worked out to be 6, 6 is bigger than 1, it diverges. So any value greater than 1 is indicating that this series diverges.